Here we have a line of positive charge. When we talk about a line, so we have a linear charge density, lambda. A semicircle of radius r equal 60 centimeter. The charge per unit length, I mean lambda, it's the charge per unit length is not constant, is equal to lambda 0 cosine theta 0 as given, as theta, not theta 0. So when you have lambda equal lambda 0 cosine theta, it means lambda depends on the angle. Lambda is not constant. So the charge is not distributed uniformly on the semicircle. The total charge equal 12 microcoulomb. It means equal 12 times 10 minus 6 coulomb. Calculate the total force F on a charge Q here, positive charge Q, which is equal to 3 microcoulomb placed at the point P. We have to find the total F at this point. Okay. Here we have the semicircle. Let's draw this line. We have the point P, and we have the vertical like this. And the angle is at this point. We have angle theta. Okay. Now, what we have also, we have the radius. We want to calculate the F at the point P. If we have here at this point a charge which is equal to 3 microcoulomb, let's say this one is capital Q and this one is Q prime. Okay, I advise you to calculate first the total field created by the semicircle at the point B without Q prime. When you calculate the field here, after you put a charge here, and it's easy to calculate F, which is equal to Q prime times the calculated E. Okay. Let's start. First of all, you have to choose a small portion of dq on the road. Okay. Let's say here we have dq. This dq has a length equal, okay, we don't have here dx, dy, okay? Here we have like this. We can say we have dl, small portion dl. It has a quantity dq. You can take dq here or here, okay? Let's say we can put dq here on the angle. It's the same here. So here we have dl with a value equal dq located at the angle theta from the vertical. It's like this. Now this dq will create at the point P a field. dq is positive, so the field must be out like this. We have dE. You know that dE equal dEx plus dEy. Before the calculation, I tell you something. When you have a symmetric object like this one, you have a semicircle and you have the vertical axis path in the center of the semicircle. You can cancel Ex or Ey. It depends the direction. How can we calculate, or how can we know which one can we cancel? Let's to know that, you take one dq here and one dq on the other side, the same height, dq and dq. Okay. Or here you have this one dq and you can take another one here. It's the same. This one on this side and this one on this side. This dE first, this one creates dEy and dEx. Okay, this one. And the left one, will create dE like this. And this dE has dEx and dEy. As you see, dq here as value equal to dq here as value, the same value. And here we have dEx, and here we have dEx. These two values are equals, but in the opposite direction. You can cancel this one and this one. And we take into account just dEy components of these two values. So like this, we know which one we can cancel. dEx can be cancelled. And we take into account only dEy. Okay. Now we come back and we continue our calculation. Okay. Oops. Okay, here. We had this one like this. Okay. Here we have DEY. Here we have DE. DEX is cancelled. And if this one, the angle equal to theta, the opposite one equal to theta. Okay. DE is equal to DEY. DEY is directed downward in the direction of minus J. So we can write DEY minus J. As magnitude DEY. Okay, before we can calculate the integral. So we can calculate the integral. E total at the point P equal the integral of dE equal minus d ey j direction. We have to calculate dEy. dEy equal, let's take this triangle, this one, and this one. To calculate DEY, here we have the right angle is the adjacent side. So it's cosine. We talk about the cosine. DEY equal DE cosine theta. And DE equal K DQ cosine theta divided by the distance square between the point and DQ, which is equal to R square. It's very important. Okay, don't forget, we have to substitute the value of DQ. Okay, so EP equal minus, I take this one, minus DEY equal K DQ cosine theta divided by R square. You know that DQ equal lambda DL. Okay, and lambda equal to lambda 0 cosine theta. We have as given here times DL. Okay, we substitute its value. EP is equal to minus, don't forget J. Okay, J equal minus integral. We can get out K is constant and lambda 0 is constant, not lambda 0. Integral of we put cosine theta dl divided by r square, and we have here cosine theta, so cosine theta square dl divided by r square. Here, be careful, because we have dl and theta. We have two parameters. We have to transform theta to L, Like this, we will get L, only L in the equation, or you can transform delta L or L to theta. Let's see. DL here, look. DL here is located between the angle which equal here, the angle here, okay? This one. This angle equal to d theta, because dl has d theta, l has theta, and you know that dl equal r times d theta. Any angle like this, if you have this is L, this is theta, this is R, L equal R theta. Okay? If the angle is small, we have here d theta, here we have dl, small l and small theta with a radius r, so dl equal r d theta. It's important. Like this, we can transform L to theta. We can write dl equal r d theta. So E is equal to minus K. Okay, again, don't forget J equal minus K lambda 0 integral cosine theta square. Look here. Here you can cancel R with R here. Okay. You will get only one R here. Okay. dl, we write d theta in the j direction. Look here, you have only theta as parameter, as a variable. Before here, we had L and theta. We cannot put the limit of the integral if you have two parameters. You have to transform all to one parameter. Now we have only one parameter theta, and we can put the limit of the integral. How can we put the limit? By moving the small dq between the extremities, between the look here, between this point to this point. We have to move like this. And we look how theta will it change. Okay? Let, first of all, theta dq is here. If dq is here, so look here, it's important, huh? So here we have theta, here we have theta positive, theta equal 90, theta equal to 0, theta equal minus 90. So we can write here, first of all, from minus 90 degree, we can say equal minus pi over 2, and also when the angle, the DQ moves to this side, you will get the angle equal 90, because it's given. You have the angle here. It's here the angle, theta. So theta here equal pi over 2. When we put dq here, theta equal pi over 2. This is the limit. We did the same calculation like before. Okay, let's we continue here. E equal minus k lambda 0. You know that r is constant. When you move this charge from the two extremities, from here to here, r is constant. Here is constant. Here is constant. Here is constant. And here is constant. So we can put out its value between minus pi over 2 to pi over 2 cosine square theta d theta. Let's continue. We have EP value with this equation. We have to calculate cosine as the integral of cosine theta square d theta. You know that cosine 2 theta equal 2 cosine theta square minus 1. So cosine theta square equal cosine 2 theta plus 1 divided by 2. We substitute this value here. So EP equals to minus k lambda divided by r. Don't forget j, minus pi over 2 to pi over 2. Let's say cosine 2 theta plus 1. 2 is constant, we can put it outside. Okay, times d theta. J equal minus k lambda 0 divided by 2r. You know that the integral of cosine, we can say k theta d theta is an example, okay? Just to understand how you can calculate cosine, integral of cosine is equal 1 over k sine k theta, okay? This is the answer. We apply here. We get here equal cosine 2 theta equal 1 over 2 sine 2 theta, and the integral of d theta equal 2 theta. Okay, So here we have plus theta. J between minus pi over 2 and pi over 2 equal minus k lambda 0 divided by 2r. We substitute pi over 2 equal half sine 2 times pi over 2 plus pi over 2 minus half sine minus pi over 2 equal 2 minus 2 pi over 2 minus pi over 2 j. Okay, let's continue here. E equal minus k lambda 0 divided by 2r. 2 and 2 sine pi equal to 0. You know that sine pi equal to 0. 0 plus pi over 2 minus 2 and 2 sine minus pi also equal to 0 plus minus times minus equal to plus pi over 2 j. So equal minus k lambda 0 divided by 2r pi over 2 plus pi over 2 equal to pi j. So this is the value of E at the point P. Okay. Now we continue. We have to calculate the total force at this point. If you don't have any charge at the point P, you don't have any force. If you want to get a electric F force at the point E, we have to put here a charge. In the question, we have a Q prime at the point P equal 3 microcoulomb. We have to find the created electric force at the point P. Without Q prime, we don't have F. With the Q prime, we have F at the point P equal the located Q prime times the calculated EP equal Q prime times EP, which is equal to minus K lambda 0 pi divided by 2r in J direction. As you see now, because Q prime is positive, FP in the direction of minus J, like EP. Q is positive, so FP and EP have same direction. This is the answer here. Okay. Let's see the direction. You know that for any point, for this point, for example, let's say for this point, the field will be down. For this point, it's like this, it's like this, it's like this. So the total field created must be downward like this. E P. If you want, we can calculate the angle of EP, which is equal to tangent minus 1 E x EY component divided by EX component. You will get this value. Okay. Thank you.